Hi guys, welcome to the Strontium Tweezer Machine lab. Today I'm not gonna talk about this machine, but I want to show you how we use Redpitaya to improve this system. In general, this system is for quantum computing and simulation in such a way that strontium atoms are cooled down in the level of microkelvin or even less than that. After that, we use the optical tweezers to trap the strontium atoms in the tweezers, and using a SLM we create different patterns of the strontium atoms. So I will show you which kind of patterns we already made with this machine. So here it is that we create in the left picture. You see that we create a quantum delta logo and the square, and the right picture you see that how we create how we sort the strontium atoms. So at the end we do the Rydberg laser spectroscopy. Rydberg laser is locked by a cavity, and also this cavity is already locked by another stable laser. One of the biggest challenge in this experiment is that because of electronical noises, mechanical noises, or temperature changes or whatever, the Rydberg laser get out of the lock. When it is out of the lock, we have to stop the experiment and relock the laser again and start the measurement again. So now I will show you how I use Redpitaya to automatically relock this Rydberg laser again without stopping the measurement. So let's go and see how the Redpitaya is installed in this system. Okay, Redpitaya and the laser driver are here. So let's go and see. I already turned off the Redpitaya to show you how it is installed in this system. Redpitaya is installed on this port. This port provides power supply for Redpitaya and also amplify the transmission signal of the cavity around 25 times more. So in this way, that transmission signal is coming to this port, and after amplifying is going to the Redpitaya. After some process, the output is going, one output is going for the piezo controller, and the other one is going for the current controller of the laser driver. So now I will install this system, and let's go to see on the laser driver how it's installed. This is our Rydberg laser driver from Optical. First of all, the cavity, it would be locked by a digilock, and after that we lock the Rydberg laser in the first level with the fork, and the feedback from the Redpitaya is coming to this analog interface to change the piezo voltage of the laser. So now let's go to the web application to show you how we should use this web application for automatic relocking this system. Okay, here is our web application, Relocking ECDL, and in the home page of the Redpitaya. If you want to have this web application, go to this web page and download the source code and upload this folder on your Redpitaya. Then you should be able to see the web application in your Redpitaya. Just be careful that you should have this file in your source code. Otherwise, you need to compile the code to have this file. And so, before going to explain this web application, I just want to show you, I just want to a little bit explain about this project that this web application is already working on. So, here is our laser driver from Optical, which is driving two ECDL laser. One is 1550 nanometer and the other one is 1070 nanometer. These two light is going to the fiber amplifier. After amplification, they are going to some frequency generation, and they will produce 6 33 nanometer light for us. And part of this light is going to the second harmonic generation to produce UV light for us, which is going to the experiment for Rydberg spectroscopy. And part of the light is coming uh, to the transfer cavity, which this transfer cavity is already locked to 689 nanometer, which is a very stable laser. And with the DigiLock, uh, we lock the transfer cavity to 689 nanometer by DigiLock, and also we lock the 633 nanometer to the cavity with the Falk, with the PDH method that it's run on the Falk. So, and also part of the light is going to the wavemeter. And here, the information of the wavemeter is on this PC which we have the wavemeter installed on that, and also we have to run the server on this PC, which the wavemeter is installed and connected to this PC. And also the cavity transmission is after amplification is going to the Redpitaya, and after some process, the Redpitaya send the feedback to the piezo and also to the current controller of this laser to relock again. If the laser is out of the lock, to relock it again to the cavity. So, and here this is our monitoring PC that we control, we monitor the wavemeter, the transmission signal, the transfer cavity lock. That's actually this transfer cavity is locked by by the server on this PC, that we can control it through this the Redpitaya. So now this is one of the applications that we are using for this web application, but you can use it for another applications for different projects. So where else you can use this web application? So here you see that in this web application there are two modes. One is the manual mode and the other one is the automatic mode. In the manual mode, you can control the piezo and also the current voltage of the laser driver. You can monitor the wavemeter, any channel that you want, which is connected to the wavemeter, and also you can monitor the cavity transmission. In the automatic mode, you can relock the ECDL only by cavity transmission. For example, you have a specific project, you don't have the wavemeter and you just only want to relock your ECDL laser just only by cavity transmission. So you are able to do that. And also you just want to lock it by wavemeter, or you want to use both the cavity and also the wavemeter. And the other thing that you can use for this web application is for relocking the transfer cavity by DigiLock. So you are able to remotely control the DigiLock through this web application, and also for monitoring the wavemeter and monitoring the cavity transmission, which is common in these two modes. So if you want to use the server, so if you want to use wavemeter and the DigiLock, you have to run the server on the wavemeter's PC. To have the source code of this server, you can go to this web page and download this code and run the server. You can simply double click on this run server batch file and run your server on the PC. But before that, you need to change some of the parameters in this batch file. First of all, you need to change this path of your activate.bat file. depends of which version of the Python you are using. You need to change this path, and also you need to give the path of where you save your server.py. After downloading this source code, you need to give the path of that file here. And here there are some parameters. One is the IP and port for the computer, which the server is gonna be run, and the other one is the DLL path and wavemeter version of your wavemeter. So usually the DLL path, it is same like here, but you need to be sure to, if it is different, you need to change it here, and here also you need to set the wavemeter version here. So this port is better to leave it on 5015 if you don't use this port for another purpose, and for the IP, but for the IP you need to set the IP. So how you can find the IP? If you go to your okay, so here is PC for wavemeter. If you come here, so if you open the batch file, and if you write ipconfig and run this command, so you will find the IP version for Ethernet adapter, that it is 192.168.0.154. So you need to give this IP address in your batch file, and after that you can double click on that batch file and run your server. So here is our server. If we run this one, so here you see that now server is starting and server is listening on this port and IP. So you need to have this IP and port for your web application. Now let's go to our web application. So here is our web application. When we go inside the web application, you see something like that. Let me change the dark mode to dark mode. Here is to run the whole program or to stop it. Here is for going to the auto lock or manual mode. Here is to run the server. It means to connect to the server on the wavemeter or a stop connection. And here we have some setting. Here we want to use the input one because our transmission signal is connected to the input one. These two parameters is to change the X range and the Y range of the oscilloscope. This part is for to monitor the transmission signal, and this part is for monitoring the wavemeter. And here and also the cavity transmission have to be connected to the input one and not input two, because the processing is based on the input one. Our probe is 1x, and our voltage is more than 1 volt, so we set it on the high voltage because the limitation of Redpitaya is plus minus 1 volt, and our signal is bigger than 1 volt. Here is for setting of input 2, output gain for channel 1 and channel 2. Channel 1 is dedicated for piezo controller, and channel 2 is dedicated for current controller. So by default, the Redpitaya is set on plus minus 1 volt. But if you want to amplify your signal to have bigger signal, to have 0 to 5 or plus minus 10 volt, you can easily change it from here, and you have to change it to apply the appropriate feedback to the piezo and current controller. Okay, and here is the setting for locking. Here you want to lock it by cavity or not, that we want to lock it by cavity. Here is the transmission level that I will come back to this value. Here you want to lock it by the wavemeter or not, and here you set your target frequency and also reference pattern. Target frequency is needed if you want to send a feedback to the piezo, and also you can send the feedback to the current, but right now we don't send the feedback to the current, so we don't need this. And here is to apply laser drift. If your laser, because of the temperature change, it has drift, so you can select, check this option, and this algorithm apply a laser drift to keep your laser longer lock. And here it is if you want to use transfer lock or not. So this option is for locking your transfer lock through this digilock. So and so we want to use transfer lock, so I will check it, and here is to control the piezo and also the current. Here is setting for the wavemeter, this IP address and the port. It is the IP address and the port that I mentioned it in the this part, that when you run your server, there is it's written that server is listening on this IP and port. So this IP and port should be written here. And this option that you want to use wavemeter or not, that we want to use wavemeter. And this is the precision of your wavemeter, that our wavemeter has 5-digit precision, so we set it on the 5. Which channel you want to monitor, that our laser is connected to the channel 1. There is to control the exposure time, and also to set on our automatic exposure or manual, and also to set switch mode or single mode. Here it is the settings for the digilock. This is the IP and port of your digilock. So how you can find this IP and port? If you go to digilock software, here this is this IP address. You need to set this IP address here. But for the port, you need to set this port number here, not this one. You need to set this port here to connect to this DUI. And here, if you want to use digilock or not, that's we want to use digilock, and this is the peak-to-peak level of your absorption signal on the digilock. So how you should find this value for your signal? So if you go to digilock, and if you should set this amplitude on the 5 volt and in scan mode. So when it's in the scan mode and your amplitude is on the 5 volt, this is your absorption signal. So this amplitude on this main voltage of this voltage, this amplitude, that if you calculated this value and this value, this would be peak-to-peak level. So for our case, for our signal is 0.4 volt. Okay, now let's run the application. Yes, so this is our application, and this is our transmission signal that you see, and this is the minimum voltage for this. And now let's run the server. So when I run the server, because here the digital is checked, and also because the transfer lock is checked, so it should come and lock this transfer lock. So let me run the server. Yes, so you see you get the information from the wavemeter, and also on the digilock you see that it starts to lock the laser to the it starts to lock the transfer cavity lock. So yeah, now this is our transfer lock is locked, and also you can see the transmission signal on the camera, like here, that this is done. And here let me show you the wavemeter. So if we change the channel, for example, if I go on channel 8, you see that it shows the information of channel 8. So, but I will go back to the channel 1, and also, okay. Now, here we can now manually control the piezo. So you see when I change the piezo voltage, you see the frequency is changing. So this is our target frequency. Yeah. So now you see that we have a transmission signal here. And if we see, we can see on the camera also, this is our transmission signal. And you see that now the level of, and here, now we can set our target frequency, that this is our target frequency, and we can set it. And we want to use locking by wavemeter also. And if I go out of the lock, so you see that this value is 2.232120. If I go out of the lock, so this value is 2.49 and 2.5. So this transmission level, when you set this transmission level should be between this when we have signal and when we don't have signal. So when we have signal, this value is minus 2.21. So I will put this value on minus 2.35 in between of when we have transmission and when we don't have. So if the transmission level is less than of this value, this program will start locking our laser. Now let's get out of the lock and start automatically, let the program to automatically lock the laser. If we click on the auto lock, you see that the program start to find the lock. So you see that how it find the lock. And let me try one more time. If I go a little far and start again, you see that it start scanning to find the signal. So this program, this web application, it somehow is intelligent, and when it get more information when, and also when it's running for a long time, it can find the lock faster. Yeah, that is the all. So if you need any information more, just feel free and be contact with me.